We're approaching half of us. Yeah, I don't know. People will be trickling in late, apparently. We're going to start a new module today. Module 7, Sequences and Series. This is fun. It kind of puts a little bit of algebra and formulas to something we've been doing since grade school. Sequences. You've been doing sequences since grade school. You learned how to count. That was a sequence. 1, 2, 3, 4, 5. That's a sequence. It's a sequence of numbers. We're just going to play around with sequences and make it more official here, put some formulas behind it, calculate some things, all that good stuff. Hello, Isaac. Welcome to class. We're about to get started here. Got my pencil good and sharp, ready for all this fun stuff. Let's see, I need another highlighter. Yeah, that one would be good, probably. All right. All right. Oh, Madison's here. Hello, Madison. All right, let me go ahead and get started here because it's going to take a while to cover. We only have one lesson, but there's a lot to it, really. So I'm going to put this up on the screen, and we're going to dig into it. You might want a pencil and paper for some notes today. Some of these formulas that we're going to derive are good to have in your notes. So remember, you can use any of your notes, and on your tests and quizzes, you can use notes. You can go back and look at the lessons to help you do things. So yeah, just remember, guys, you can use your notes. You can go back and look at lessons when you're doing assignments and tests. I want you to do that. Let's see. Let's go to our grade screen. We scroll down here. We see all this wonderful work we've completed. Hopefully you are finished with the exam from Module 6. If so, then you are current, good to go. But if you have any zeros when you go scrolling up through the grade screen, that's why this is a great place to go every week. Go to the grade screen in Buzz and see if there's any zeros or any low numbers you would like to be larger numbers. All right, but we should be down here at Module 7, Sequences and Series. That's only lesson. We're doing one lesson a week for the next 4 weeks here. So that's good because he's got a little bit in these lessons. There's a lot. Next week, we're actually separating sequences and series into 2 different lessons. So we're going to spread that over 2 weeks. But we're doing arithmetic sequences and series all at the same time here. So let's go to activities, take a look at our lesson. I say I've closed those other folders. We're done with them. Let's look at this lesson here. Oh, there we go. All right, we got an activity. I'm going to make sure I got the chat open up so I can see it. Got the chat. Okay, got the chat open so you can participate. And I'll make this a little larger to make it easier to see on the screen. All right. So we're going to be showing a list of numbers separated by commas. This is a sequence. So we got to fill in the blank. What is the next 3 numbers? What I should say that properly. What are the next 3 numbers of this numeric sequence? This arithmetic sequence starts with 8, 23, 38, 53, something else, and another something else. This is the classroom participation portion of our lesson today. Okay. Mary thinks that this next one should be a 68. So we'll type a 68 in there. I still have the cursor there if we need to change it. Everyone like 68? If you're not sure what's going on here, just go to like the second number and subtract the first one. Or go to the third number and subtract the second one. Or the fourth. Just go to a number and subtract the number in front of it to see how much was added. Right? So if you need to get your calculator out to be able to do this, that's fine. Get your calculator out. So 23 minus 8. Minus 8. Oh, apparently it went up 15. 38 minus 23. I'm betting Mary did this in her head here. Oh, it went up 15. 53 minus 38. So every time it goes up 15. 15, 15, 15, 15. So 53 plus 15 is 68. 68 plus 15 is 83. 83 plus 15 is 98. And we just go on and on and on. That's what the three dots are. On and on and on. That's correct. 68, 83, 98. All right, let's see if I can make it a little tougher. Here's the next one. -5, -7, -9, -11. It's obviously not adding 15 this time. I'm not going to fool Mary, though. She's on top of it. Not going to fool her. Now, this one's going down, obviously, right? -5, and then -7, and then -9. And so this is going down 2. So every time we're adding -2 or we're subtracting 2. That works both ways. Subtracting 2, adding a -2. -13, -15, -17. Submit. Yes, that's excellent. That's the next three terms. All right. Gonna have to take it up another notch. How about this one? Ah, yeah. All right, for all you folks doing it in your head, let's see if you can do this one. 3, 1.75, 0.5, -0.75. We can see the numbers are going down. They're getting smaller because it starts with 3 and all the numbers after that are less than 3. We see we've got decimals in here. We're like, oh my goodness, Mr. Brock, you're bringing decimals into this. So what's going on? 3, 1.7. It's going down 1.25 each time. So if we subtract another 1.25, it is at -2. Some of you folks are on top of that. And then -3.25, and then -4.5. That's our sequence. Submit. Excellent. All right, last one. See if I can get you this time, right? No, it's still just decimals. We didn't really make it harder. In fact, we're actually going up this time. But I'm only giving you 3 numbers instead of, 2.5, 3.25, and 4. But you can still tell from there. It's not that bad, right? You guys were all over the negative one there. You had the -2, -3.5, -4.5. How about if we're going up? Again, if you need to just get a calculator and subtract going backwards, what's the difference between 4 and 3.25? Or the difference between 3.25 and 2.5? It's going up this time, right? 4.75. It's going up 0.75 each time. So we just have to add that 0.75. 6.25. We'll submit. Excellent. All right, so you guys know what an arithmetic sequence is. I think you've got that down pretty well. All right, let me make this back to normal size so we can see what's going on the rest of the page. All right, so we are going to learn how can an expression or a process be determined for an arithmetic sequence, some kind of formula. What functions combine to create an explicit formula? Oh, we've got some vocabulary coming in here. Explicit. What possible restrictions exist on domains and ranges of arithmetic sequences? And how can an expression or process be determined? All right. So I just said that you guys obviously know what an arithmetic sequence is. Now we have a little quiz on whether or not this is an arithmetic sequence. So how about this one here? 1, 2, 4, 7, 11. Is that an arithmetic sequence or is that not an arithmetic sequence? We just said an arithmetic sequence, the ones we looked at, added the same number every time. Sometimes it was 1.25. Sometimes it was a bigger number or a smaller number. Mary says this is not an arithmetic sequence. 1, 2, 4, 7, 11. Well, it's a sequence of numbers for sure, but it's not arithmetic because we add 1 and then we add 2 and then we add 3 and then we add, that's not the same. 1 and 3 are not the same. I've studied math a long time, and I know 1 and 3 are very different. So we're going to put that in the not an arithmetic sequence category. How about this one? 3, negative 147, negative 297, negative 447. Is that an arithmetic sequence or is that not? Danush says, yeah, that's an arithmetic sequence. I mean, numbers are using bigger numbers in a hurry, or smaller numbers really, because it's going negative, right? But right, every time we're adding negative 150. That's the difference between each one. Negative 150. It goes down to negative 150 each time. So that is an arithmetic sequence. So we're happy with that. How about this one? 10, 8, 12, 10, 14. That's interesting. So it goes down 2, and then goes up 4, and then down 2, and then goes up 4. Well, there's a pattern there for sure, but it's not the same every single time. It has to be the same thing that you're adding every time, and it's not. Oh, they end up with an easy one. 4, 14, 24, 34. You could probably guess the next number. Yes, it's 44. Yes. You got it. That is definitely an arithmetic sequence, adding 10 every time. So this just tells you why or why not that it's an arithmetic sequence. It has to be the same common difference every time. Ooh, there's more vocabulary words. Common difference. Let's go to page 2 and dig more into this. All right. A sequence, this is important. A sequence can appear in multiple forms. We were just looking at a list of terms. The first term of the sequence is 3, the second one 6, the third term is 9, the fourth term is 12. But it could be in a table. Here's the exact, all 3 of these are the exact same sequence. This one, look, it has an N. That's saying the first term is 3. The second term is 6. The third term is 9. The fourth term is 12, which is also illustrated in this graph. First term 3, second term 6, 3. And this is how you graph a sequence, by the way. Notice those dots are not connected. There's no line connecting those dots. Can you guess why? I'll give you a chance to show off here. If you can actually guess why, I want you to have the opportunity to share that knowledge if you have it. Why do we not just draw a line and connect all of those? It's obviously a straight line. Any thoughts? Just give me a chance. I don't expect you to know the answer, but I thought somebody might have a good guess on why we do not connect the dots. All right, I'll tell you. I'm keeping you in suspense long enough. I know you're dying to know. You're like, tell us, Mr. Brock. Tell us. Come on, Mr. Brock. Tell us. All right, I'll tell you. Because there's no 1.5 terms in our sequence. I can ask you what's the second term in the sequence, and you'll tell me 6. And I'll say, well, what's the 2.7 term in our sequence? Well, Mr. Brock, there's nothing between the second term and the third term. The second term is 6 and the third term is 9. There's not any terms in between there. That's right. That's why we can't connect them with a line, because then the line would show lots of points in between there. But they don't exist. The only thing that exists in our sequence is the first term, which is 3, and the second term 6, and the third term 9, fourth term 12. There are no values for this sequence in between those numbers. So this is called a discrete graph. Not because we're being hush-hush about it and don't want a lot of people to know, but mathematically it's spelled discrete. That means there's spaces in the graph. It's not a continuous line. There's spaces. It's a discrete graph. So if you go into college, there's a whole class called discrete math. When we connect it all, it's a continuous graph because we connect all the spots. So a line. All right. So we're going to add 2 points of vocabulary here. Recursive and explicit. Sounds like we're rating movies or something, doesn't it? Yeah. Recursive and explicit. So recursive This requires the use of the previous term in a sentence. Like when I go up here and I show you this 3, 6, 9, 12, and I ask you what's the fifth term in the sequence, well, that's not too hard because we know what the fourth term of the sequence is. And we know if we just add 3, that will be the fifth term of the sequence. You'll say, it's 15, Mr. Brock. That's easy. I said, great. What's the 33rd term in that sequence? And then you're like, can you tell me what the 32nd term is? Because if I could tell you the 32nd term, you could tell me the 33rd term. That is the recursive method of finding the terms of a sequence. As long as you know the term before, you can add the common difference and tell what the term after it is. So we have a formula for that, and I'm going to put it up here on the screen so we can start taking our notes for today. So let's see, with arithmetic sequences, so let's title our notes so we know what we're doing. Oh, some spammers are really wanting to talk to me today. Arithmetic sequences. All right, this is the recursive formula. If we want to find some term, and we'll call that term a sub n, right? This is how we label terms in an arithmetic sequence with an a and an n. All we have to do is find the term that's in front of that. Oh, I need to make that a subscript, not equal with the a down here. And then add whatever the common difference is. So let's give ourselves an example so that we know what we're talking about. If we have this sequence here, let's make up a sequence. 2, 6, 10, ... 2, 6, 10. So we know the common difference, and this is what D stands for. D is the common difference. See, D equals, put this in our vocabulary, common difference. That means, what does each of these have in common? What is the difference? When we subtract 10 minus 6, the difference is 4. When I subtract 6 minus 2, the difference is 4. They have that in common. So D equals 4 for this sequence. So if I want to find the fourth term, a sub 4, I'll make the A look like that, maybe kind of make them a little fancy typewriter A's. A sub 4, my formula says if I can find what a sub 3 is and add the common difference, then I'll know what a sub 4 is. Well, I know what a sub 3 is. The third term is 10. The common difference is 4. So a sub 4 equals 14. That's the fourth term in the sequence. Well, it's like, oh yeah, I can tell that, Mr. Brock, because I can see 2, 6, 10, and 14. Yes, recursive is very simple. If you know the term before it, just add the common difference. Not very tricky right there. Let me highlight that as our first formula of the day, recursive arithmetic sequence formula, with a little example in our notes there. All right. So it talks about the right here with the n minus 1. That just means the term before it. And recursive takes which means again. So a recursive process is where each term must be known and the process is applied again and again and again. So as we want to know each term in the sequence, we've got to keep doing that again and again and again. Let's see what it says about explicit right here. An explicit formula allows you to calculate any term directly. Like if we were asked to find the 45th term of a sequence that starts 2, 9, 16, it's like, okay, well, I know I can just keep adding 7 until I get 45 times. But Mr. Brock, please tell me there's a better way. Well, there's a better way. So let's talk about how we would know that. 2, 9, 16. We know it's just adding 7. So here's what we know about this. The first term is 2. We can see that. It's a 2. 2 is the first term. If we want to find the second term, we just add 9, right? How many times do we add 9 to get to the second term? Just once. See, one time we'll add 7, and that'll give us a 9. What if we wanted to know the third term? Well, we could add it to the second term, but what if we started with that first term every time? Every time I'm going to start with 2. Now I want to know the third term, so I need to add 7, and then I need to add 7 again. I got to add 7 twice. So the third term would be 2 plus 7 plus 7. Right, 7 plus 7. Or I can just say 2 times 7, because that's the same thing as plus 7 plus 7. I'll just add 2 times 7. When I want to know the fourth term, I add 7 3 times. This is kind of all giving us an idea on how to come up with a formula. In fact, let's jump to a formula right now. I know they're taking the long route. We're too impatient for that. So what we were looking at there, we're going to call this the explicit formula, because we can explicitly jump straight to a term. If I want to know what the a sub n term is, if I know the first term, we were using the first term every time. So if I go to a sub 1, and what I was doing on that sequence is I was adding the common difference a number of times. How many times was I doing it? Well, like for the fourth term, I added the common difference 3 times. 7, 7, 7, which means 3 times 7. So this number that I multiplied the 7 by was always 1 less than whichever term I was looking for. The second term, I multiplied it 1 time. The third term, I multiplied it 2 times. The fourth term, I multiplied it 3 times. The fifth term, I multiplied it 4 times. So if we multiply it, the common difference times n minus 1, that will give us explicitly the term. I don't have to figure out every term in between there. In fact, I'll even put a little orange on this one. Explicit. Let's try that with our little sample we were doing here. We have the 2, 6, 10, common difference is 4. And now I want to know the 73rd term of this sequence. What is the 73rd term? 2, 6, 10, etc., etc., etc. Well, let's use this explicit formula. If I want to know a sub 73, because I want the 73rd term, it says I can take a sub 1, and I'll do it again down here. A sub 1 we know is 2, plus the common difference times 73 minus 1, right? Because n is 73. So the common difference for our sequence right here is 4 times 73 minus 1 is 72. So a sub 73 equals 2 plus 4 times 72 is 288. So the 73rd term is 290. Hey, that was a lot easier than counting 73 terms. 2, 6, 10, 14, 18, 20. I'm going to get tired before I get to 73 terms. But with the explicit formula, we can jump straight on it. So these two formulas are going to be very useful when talking about arithmetic sequences. That's why we put them in our notes. So let's see. They're going to find a formula by taking the 5th term and working backwards. I'm going to skip that. If you want to watch it, it's like a little 45-second video, I think. Oh, it's 1:05. But we've already got the formula that they're still trying to figure out there. So here are the two formulas, recursive and explicit. So this is what you should have in your notes, or use this, print this page off of your notes, or however you're taking notes. But the important things to know is a sub n, which means whichever term you're looking for. If you want the 11th term, then it's a sub 11. If you want the 20th term, it's a sub 20. N minus 1 is just the same number, minus 1, and then D is the common difference. So, all right, let's move on to the next page. So it's talking about where this formula comes from, this A1 plus D to N minus 1. It's really a combination of two different functions. The A sub 1, that never changes. The first term of the sequence is always going to be the first term of the sequence. It doesn't matter how many numbers we count, the first term always stays the same. In our 2, 6, 10 sequence, 2 is always going to be the first number. No matter how we calculate things, it's always the first term in that sequence. This changes. So, that would just be like a straight line if we just graph that. N minus 1 will change. The common difference stays the same, but which term are we looking for? So that N minus 1 will be a diagonal line, and the slope will be whatever the common difference is. The D would determine the slope. And it's just how many terms are we going up that line. So let's talk about the domain and range real quick. This is the only place that we're going to talk about this in this lesson, but you'll have an answer in a question in the quiz that asks about this. The domain. To really understand the domain, let's go back to how we can look at this in different ways. Like right here, if we put the same sequence as a table or a graph, the x's is the term number. Term number 1, term number 2, term number 3, term number 4. So in a sequence, that is your x values. That is your domain. So looking at that, the domain never changes on a sequence. Never, never, never. It's always all integers greater than 0, or all integers greater than or equal to 1. Because basically the domain is always 1, 2, 3, 4. Because you can't have a 1.5 term. You can't have a 0th term. I can't say, okay, tell me what is the negative 5th term of this sequence. You're like, the what, Mr. Brock? The negative 5th term of the sequence. There is no negative 5th term. It's like measuring how long something is. You can't say it was negative 11 inches. There's no negative values when we're in the real world. So if we're looking at a sequence of numbers, the domain is always all the integers 1 and greater. So that's what they're talking about when we got on the domain and range right here. The domain, the sequence is a set of numbers, and we count the terms as the first term, second term. It would not be appropriate to have a negative term or a decimal term or a fraction term. So the terms always start at 1, first term. So the domain for arithmetic sequences is all integers greater than or equal to 1. Always. And if you remember that or have that in your notes, that'll help you get one question on our quiz this week, on our assignment this week, because it's going to ask about the domain. The domain. And if you remember, the domain's always 1, 2, 3, 4, 5. Yeah, that'll help. The range can change, right? Because we looked at all kinds of different numbers on our sequence. It could be any number. On our 2, 6, 10, the range is, everything greater than equal to 2. But we had some of them that were going negative, so the range could be negative numbers. The range can change depending on the sequence numbers. All right, so we're going to look at an example, and we're going to work this on our paper because we need some practice doing this. So a sub 1 is negative 22. A sub 12 is 77. So it wants us to find the 46th term of a sequence where the first term is negative 22 and the 12th term is 77. Wow. Mr. Brock, you didn't even tell us what the common difference was. No, we didn't. All we know is the first term and the 12th term. That's it. But fortunately, we do have a formula that we could use. If we take this formula, a sub n equals a sub 1 plus the common difference times n minus 1. And let's plug in what we know. Now, they want to know the 46th. We're not there yet because we have to figure out what D is. We don't know what D is. So if we know the 12th, let's use this formula to figure out D was. What's A sub 12? Well, A sub 12 is 77, right? We're using the formula to find A sub 12, which we already know the answer to. And we already know what the first term is because they told us. Negative 22. And this is D. We don't know that. D. But we know what N minus 1 is because we know that this is the 12th term. So N minus 1 is 11 because this is the 12th term. So now look, we have all numbers with a D. We can solve this for D. So let's add 22 to both sides. I know there's some problems like this week that they give you this exact same scenario. So having stuff like this in your notes will make that so much easier. 99 equals 11D. Hey. Solve for D. So divide by 11. 9 equals D. Okay, so the common difference is 9. We found the common difference. That's great because now with our formula up there, we can find the 46th term like they want us to. So the question says, what's the 46th term? So I'll do the fancy A. A46 would be A sub 1. Well, that never changes. It's always the first thing. Every time we use the same sequence, it's always going to be the same first number. In this case, negative 22. Plus D, we just calculated. We know what D is. N minus 1. What's N? In this case, A sub N is 46. So this would be 45. Because 46 minus 1 is 45. Now we just have a very grade school math problem to solve here. So let's put our calculator back up. Okay, so let's put this in our calculator and find out what negative 22 plus 9 times 45 is. Let's see. All right, so we'll go negative 22 plus, and I'll put in parentheses just to make it easy, 9 times 45. That's 405. That's what 9 times 45 is. And added to the negative 22, 383. That is the 46th term in this sequence. 46, 383. Does that make sense? Well, let's see. It goes up 9 every time. So that's a little less than 10. If it went up 10 every time, that means it'd go up like 460. Starting at a negative 22, but it only goes up 9. So that's about right. So we can trust that to be a good answer. 383. Let's see what they got. First, they found D, which we did the same thing. It was 9. And then they used that to find 383 as the 46th term. And here's another example if you want more practice. There's also practice problems towards the end of the lesson, right? It says find the 29th term, and they gave you this sequence, 11, 8, 5, and 2. And then they show you how to do it. So if you don't want to know how to do it yet, do it on paper before you look at that. All right. Yeah, page 5 will have practice problems. Let's look at a series now. Arithmetic series is very, very similar to a sequence. Let's talk about a series here real quick. Okay, so an arithmetic series. Arithmetic series would be, let's use the same one we were using up here, 2, 6, 10. That would be the sequence, but the series would say 2 plus 6 plus 10 plus ... The series is the sum. If we add this sequence up, what does it equal? Well, that's going to depend. How many are we adding? Are we doing the first 5 terms? Are we doing the first 15 terms? How many terms are we adding? But it'll get big in a hurry because these numbers will get bigger and bigger and bigger that we add on there. So we're going to come up with a formula for that too. But a series, the difference is instead of commas, it's addition. This had commas. Sequences have commas. Series have plus signs. All right. So that's the big difference. So it wants to know then, here's series, here's sequence. Which one's this? Well, we just said that a series has plus signs. So that's a series. Hey, that's the same sequence we saw earlier in the lesson. We know that's a sequence. It's got commas. Look at that. That's got commas. That's the first sequence you ever learned right there. You learned that one back in kindergarten, right? 1, 2, 3, 4, 5. That's a sequence. Adding 10 plus 8 plus 6. So that's a series. All right. That's not too hard. But if you need that refresher, you can always go back to page 4 here and do that on your own buzz. All right. So let's see. They're going to have this video here, which is going to say, how can we figure out a function or an equation that would help us add these up? So here's this series, 4 plus 1 plus -2 plus -5 plus -8 plus -11. Let me see. I don't even think this one doesn't even have any words. It just plays it. So we'll put it up here. All right. So it has this series and it says, well, if I took the first number and the last number and add them together, I get -7. Then the next numbers, if I start working in, that equals -7. Then I take the 2 middle numbers and add them together. That equals -7. So there's something in common about taking a sequence of numbers and adding the first one and last one together, and then the next 2 together, and the next 2 together, and so on. They're always going to have that same value when I add them together. Interesting. That gives us a hint towards what we're doing. They keep coming up with -7. All right, before we go on, they want us to do a little vocabulary check. We've been using different words, so we need to make sure we understand some vocabulary. I'm going to make this bigger, so it's bigger on your screen. Can I go one more? Nope, that's too big. All right. Get that out of my way. All right, here's our variable. A sub n, A sub 1, n, and d. And here's 4 definitions. So let's start with an easy one. How about A sub 1? What's the definition for A sub 1? And we can just say A, B, and C, and D if you don't want to type all this. A, B, C, or D. If we're talking about A sub 1, which one is it? A, B, C, or D? Just to make that easy on you. Mary says it's C. Madison agrees. Yeah, A sub 1 would always be the first term in the sequence. So if we click that, it disappears if we're correct. How about D? D is another one that we should know. We're using that in all these equations. D is in there. So we need to know what D is. Is it A, B, or C? Mary says it's the common difference between the terms. Yeah, that's where the D comes from, actually, the word difference. D is difference. That disappears. Oh, now we've got A sub n and n. And we have the number of terms or the last term. Let's see. So A sub n. Is that going to be A, the number of terms in a sequence, or B, the last term in a finite sequence? Notice if it's an infinite sequence, there's not going to be a last term, right? So that's why it says a finite sequence. And also, if it's an infinite sequence, there's not going to be a number of terms. So Mary thinks A, but not quite as confidently A this time. We have a question mark A. Is A sub n the number of terms, or is it the last term? All right, we need somebody else to weigh in here. A sub n. Is it going to be A, the number of terms, or B, the last term? Our other choice is n. What is n we're going to represent? We have n, we have A sub n. That's our only two choices. Right now we're trying to figure out A sub n. Danielle says, yeah, I think it's A as well. Anybody else fall asleep? Is this A or is it B? A sub n. A sub n. Oh, you know I'm going to be playing elevator music when I edit this video. Right here, just kind of like, you. I think we're all waiting in an elevator. All right, we're gonna choose this and see what happens. All three of you think A, and when I click A, that was incorrect. Oh, so n is the number of terms. N is the number of terms right there. A sub n is what we call the last term. All right. So if you're not sure about that, maybe you should go take that quiz yourself. Make sure you get it right. All right, let's go back and make this smaller again so we can see more. Feed me, Seymour. All right, let's see. They were adding the first and last together to find that -7 up here. That kind of gives us a hint towards a formula for an arithmetic series. So it says using sum of all these variables, A sub n, A sub 1, n, and d, write a mathematical expression that would allow you to find the value of -7 from this series. All right, so let's try that. That sounds like a challenge. So using A sub 1 and A sub n and d, how would we do that? They had, what was their series they did? 4 plus 1 plus -2 plus -5 plus -8 plus -11. -11. Looks like a 71 now. I got my negative didn't have room. Plus -11. All right. So this is a sequence which has 6 terms. And they added the first term and the last term. So added A sub 1 plus A sub n, and that equaled -7. Okay, so A sub 1 plus A sub n, first term and last term of the finite sequence, got us to -7. All right, so all they wanted us to do on that, let's check our answer. There it is. A sub 1 plus A sub n was able to do that. That's how they did that in the video. And we know that's being multiplied by 3 to find the sum because they did it 3 times. -7 plus -7 plus -7. So how can we get a value of 3? So we know A sub 1 is 4. We know A sub n is -11. We know n is 6. And we don't really know the common difference is -3. Because we can look at that and tell that there's a -3 between each term. But if we want just the number 3, we can do n divided by 2. That's 6 divided by 2 equals 3. And if we multiply 3 times -7, that's the total. This adds up to -21. It adds up to -21 because it added up to -7 plus -7 plus -7. So that'd be -21. You can put that in a calculator if you want to verify that, but this adds up to -21. So if we multiply these two things together, n divided by 2 times A sub 1 plus A sub n, that would give us the -21. Oh, looky there. I think we've got our formula. Yeah, n divided by 2 gave us that. So let's go to the next page. Oh, let's find the formula for arithmetic series by working backwards. They're going to take that negative 21, work backwards.
The sum of the 6 terms of the arithmetic sequence is negative 21. Negative 21 can be rewritten as 3 times negative 7. 3 represents the number of pairs in the arithmetic series, and negative 7 is the result of negative 21 divided by 3. The 3 pairs in the arithmetic series can be written as 6 divided by 2, where 6 represents the number of terms in the series. Negative 7 can be written as 4 plus negative 11. 4 represents the first term of the series, and negative 11 represents the last number of the series.
Okay, that was it. Short and sweet. So by adding the first and last terms and multiplying that value by the number of pairs, we get a formula. So we're going to add this to our notes here. Arithmetic series. And notice we used a sub n on the front because that's just where we found that number of term. The arithmetic series is an s sub n. So the sum of however many terms, like in that case it was 6, the sum of 6 terms, can be found by taking the number of terms and dividing it by 2 and multiplying that times the first number plus the last number. All right. S of n equals n divided by 2, a1 plus an. So let's see. We need an example to use on that. Let's just use the most basic sequence. Here's a sequence. 1, 2, 3, 4. You probably know that sequence. You may be familiar with that. Here's a sequence. And I want to find S sub 25, which means I want to add up the numbers 1 through 25. So S sub 25 would equal 25 divided by 2 times first number of our sequence is 1. The 25th number, if we're adding up the first 25, would be 25. So that would be 25 over 2 times 26. Let's pull up our calculator again so we don't mess it up. 25 divided by 2 times 26. So 25 divided by 2 times, that's 12.5, we knew that, 26, 325. So if you add 1 through 25 together, 1, 2, 3, 4, 5, 6, all the way up to 25, that totals 325. Well, that's kind of cool. It's a multiple of itself, too. 325. All right, so this is great if we know the first and last. Here, I'll highlight this so we can have this formula in our notes. If we know the first and last number in that sequence, right? It's like, okay, that's great. We can do that. And here's where they did a different one there. So what about one of those cases where we don't know what a sub n is? Okay, so we're going to do a different one. Let's say we've got the sequence 2, 7, 12, 17, et cetera, et cetera, et cetera. So we know it goes up 5 every time, but we want to find S sub 33. I want to add the first 33 numbers together in that sequence. And you're like, but wait a minute, our formula, we have to know the first one and the 33rd one. We don't know the 33rd one. You're correct. We don't. Let's see what we can put together here. N2 times A1 plus. How do we know what A sub n is? How do we know what the 33rd is? Oh, wait. We have a formula to find the 33rd term. That was back here. We can use this as an explicit formula. This will tell us what the 33rd term is if we know the first one and we know the common difference, which we do. So we can take this part right here, A1 plus Dn minus 1, and put that here. A1 plus Dn minus 1. Gotta get all the parentheses in there. Yeah, okay. So we stole this formula from the arithmetic sequences formula. Because we said we don't know what A sub n is. We don't know what the 33rd term of this sequence is. But this formula tells us how. So let's simplify this formula now. N divided by 2 times A plus A1 plus A1. 2 times A1 plus D times N minus 1. And that'll give us basically any number if we don't know that last number. So this is like the recursive. This is like the explicit. This will jump straight to any number. So we can use that to find the 33rd term here. Let's see if we can actually do that math. So the 33rd term of this sequence would be 33 divided by 2, because it's n divided by 2. N is 33. Times 2 times the first term. The first term is 2. So 2 times 2 is 4. Plus the common difference. We can see the common difference. It's 5 times n minus 1. Again, n was 33. So it's 32. So it's 33 halves times 4 plus 5 times 32. Well, 5 times 32, that's 160. So this is 164. So we take 164 times 33 halves. All right, 16 and a half times 164. 164. That's what it adds up to. 2,706. So if we start with 2, 7, 12, 17, and we go all the way to the 33rd term and add all those together, plus, it equals 2,706. We have a formula to do that. N divided by 2, 2 times the first term, plus D times N minus 1. Let's see, they get that? They put the N minus 1 times D. That's the same thing, right? D times N minus 1, N minus 1 times D. All right, so that is the arithmetic series formula if we don't know the first back. Now here's some practice. So they give you some practice problems here on page 5, which is the last page of the lesson. So you can do these. What's the sum? Oh, sum, that means you're using the series formula. Sum is series of a 44-term sequence where the first term is -9, last term is 120. Oh, they gave you the first term and last term. So that means you can use this formula because you have the first term and the last term. If you have the first and last numbers, they go there. If you don't know the last term, you use this one. So what's the total? All right. So there's 4 of those, and then there's more practice problems over here. What is the first? Oh, they don't even give you the first term in this one. Of a sequence, this is not the series. Go back to the first formulas. The last term is negative 12, and the sum is 42. Oh, now they give you the sum. So they gave you the number of terms, the last term, and the sum. So that means you could go to this formula because you know there's 14 terms. And you know what the sum is. You can replace this number with the total. This would be a 14. This would be the last term. And you just solve it for A1 because you'd have all the other variables filled in. Just fill that in. All right, lesson summary right here. It should have all those formulas that we put in our notes. You could just print the summary and use it as your notes if you like. It talks about arithmetic sequence, both the recursive and the explicit formula, and then the 2 formulas to use for an arithmetic series where we're taking the total, the sum, the 2 different formulas you can use for that. All right, let's look at our assignment. Oh, that was our assignment. I just blew right past it. Start. Identify the 35th, 31st. Yeah, that's a term of an arithmetic sequence where here's the first term and here's the 18th term. So you got to find that common difference, and then you can use the other formula to find the 35th term. What's the 27th term when we give you the first and 17th term? Here, the seats at a baseball stadium are arranged so that each row has 5 more seats than the row below it. So if the very first row only has 4 seats, that's going to be a weird looking baseball stadium. Only 4 seats in the first row. How many are in row 23? You know what the common difference is because it told you there's 5 more every row. Common difference. So you can just use your arithmetic sequence formula to find out row 23. You've got the first row, you've got the common difference. Given these 2 functions, 11 and negative 2 times n minus 1, combine them. That means add them together, right? Combine means to add. Add them together to create arithmetic sequence. Which one would it be? 11 minus 2n minus 1, 11 minus 2n minus 1, 11 plus 2n minus 1, 11. And what is the 31st term? So you can eliminate half of them by 2 of these choices are subtracting, 2 of them are adding. And then what is the 31st term? And then this last one, given an arithmetic sequence, here's the sequence, 40, 47, 54, first term, second term, third term. Create an explicit formula and list any, here it is, restrictions to the domain. What's the domain of this sequence? Hint, we've talked about this, it's the ends. So which one of those apply? N has to be what? Look, there's even N right there, and they're asking you about ends. So, all right, 5 questions, guys. Arithmetic sequences. We're going to do geometric sequences next time. This was arithmetic, adding arithmetic. Geometric, we get into a little more exponential type talk. So, all right, guys, that's it. 1 assignment this week, 5 questions. So if you're behind on anything, get caught up. These next few weeks, we're just going to have 1 assignment each week. So it's a great time to go back and pick up any zeros that you have in the grade screen and buzz. But otherwise, go enjoy the rest of your week. I'll be here Friday for anyone that has a grade below 70. By the way, if you have your grade below 70, get your grade above 70. You won't have to come Friday. I'll dismiss you. But anyway, have a great week.